Hey, what's up guys? My name is Achano. Welcome back to another code review, the series in which you guys send me your code and your projects and I take a look at them. If you have a cool project you'd like me to take a look at, then check the description below. There's some instructions on how you can send it in. Today we're going to be taking a look at something a little bit different than usual. We're going to be taking a look at a chess clone. Now, I'm not really sure what like a chess clone is because like chess is not like a video game, I guess. I think this is just a chess game because the original chess board game, I guess if you made a board game, that would be a chess clone, right? Anyway, I'm not sure how many of you are fans of chess. I am a fan of chess. That's why this kind of stood out to me. I don't think anyone sent me chess before. Okay, I stand corrected. But anyway, I guess Julian really lucked out here because we're going to be taking a look at this today. I'm a huge fan of your C++ series and your code reviews. Videos are always helpful for me. I'd like to thank you for that. Thank you. I created a chess clone in C++ with SDL2. It basically initializes the field, renders the pieces, calculates possible moves and game states, and prints out the winner at the end. Every piece has got its own class, derived from a base class called piece. Lovely, lovely object-oriented programming. It works fine. By the way, that was like half a joke and half not. I know that a lot of people like to bash on like object-oriented programming. I'm not really here to bash on this, especially because this person is likely like a beginner. Let's just dial down the hatred. It works fine and I couldn't find any bugs yet, but I'm pretty sure the code is not very well written. Okay, cool. Here's a link to the repository, which we will take a look at in a minute. It would be an honor if you could review my code and tell me a bit more about what exactly could have been written smarter and stuff like that. Okay, so just general kind of advice, I guess. I'm 22 years old and a statistics student from Germany who got into programming at my university. I don't really care if my name is displayed or not. I'm not really sure if the build process works if you just clone the repo. Oh my gosh, everyone and the builds, man. What is it with you people and just making code that just builds? I'm honestly considering just making a video dedicated to like how to build C++ code, how to make a repository, how to make a project, and then just build it, how to distribute that, how to build. I never learned stuff like that, and it's much self-taught knowledge. I'm already excited about your response. Well, luckily I am responding. Hello again. Hello again. I rewatched the code review of yours and made some mistakes previous people also did. Like not putting SDL2 into my project. I tried to fix that, messed up everything. I'll text again when it works like it should. Thanks. Sorry, these code reviews are just getting very boring. Hello, one last time. Hello, one last time. After some painful hours of trying to set up the repo, I think I'm finally done. It should now be possible to just follow the steps in my README and have a fully working project. Sorry for the spam and thanks for being patient. All right, so what we're going to do with today's video, right, is we're going to not go over the build process. I have done this pretty much every single code review episode almost. I've gone through and fixed the code, given advice on how to make code that is buildable, that will just work, that you can just clone, set up properly, how to do that, relative parts, absolute parts, literally covered all of that. Go through the past code review videos if you are interested in seeing that. I'm going to cut that out of today and we're just going to cut exactly right now to the code. But first, this video is sponsored by Skillshare. For those of you who don't know what Skillshare is an amazing online learning community that has thousands of different classes on literally every topic imaginable that is designed to help you learn new skills as quickly, smoothly, efficiently as possible. They have classes on like literally everything. If you're trying to learn more about photography, videography, how to make YouTube videos, illustration, productivity, marketing, singing, I could probably benefit from that. Skillshare have got you covered with plenty of amazing classes to choose from. And one of the things that I really like about these classes is that they're not like, they're not like lengthy. They're not just stretched out. They're very much to the point. They're not optimized for YouTube where like watch time matters or anything like that. They are specifically their own platform designed to make learning as easy as possible for you. And the cool thing is that Skillshare is offering the first 1,000 people who click the link in the description below a 1-month free trial of Skillshare Premium. You'll be able to check out their entire library of classes and see if there is something there for you. So definitely go ahead and do that. Sign up for the 1-month free trial and see if there is something there that floats your boat. Huge thank you as always to Skillshare for sponsoring this video. And over here, as promised, we see the code. Does it run? Of course it runs. Did I have to spend hours figuring out how to run it? Of course. No, I'm kidding. It wasn't like hours. It was like maybe 10 minutes, but anyway, we're here. So F5, and this is the game. This is the chess clone. So I'm assuming white moves forward. Yes, just checking, relax. I know how to play chess. So we click. Okay, so we have to click and hold, I guess, and then we can drag this over here. Okay, let's play a game of chess. What are we thinking? Like Bong Cloud opening? Probably. Okay, so the knight seems to move as normal. I mean, I'm just going to try and, I guess, evaluate the pieces. I don't even know how I should be testing this. Let's see. Oh, can't castle. Okay, so that's a problem. We definitely want to be able to castle. I'm assuming, well, if we do it that way, it's just going to move the rook. Yep, can't castle. Also, I'm noticing the extreme kind of blurriness of the pieces for some reason. We'll check that out in a minute as well. But otherwise, I guess it's a pretty functioning game of chess. Again, apart from the lack of castling. I'm just going to go ahead and try and like checkmate. Let's see, what's a quick little checkmate I can do? I guess what we should probably do is, yeah, like let's take a piece. Okay, that works. Yep. This is pretty cool and quite functional. What I was going to do, let's test the check, right? So here's a check. Can I just move the bishop? No, I can't. Doesn't say check or anything, but that's okay. I can move the king. Can I block? Yes, I can block. Maybe like move this here. Move this here for a little check. Okay, white is in check. That doesn't indeed seem to be working. This has just become like a chess video, really. I mean, I'm not sure what you guys expected. Who needs C++ code? I am entertained. Would have been nice to have like some kind of chess AI, but I guess this will do. I guess I'll retreat from my Bong Cloud. I guess we should, let's go ahead and be aggressive. Okay, fun time is running out. That was actually a mildly annoying move. Well, actually, it doesn't matter. He doesn't have to take it. Let's just say he goes here and we can, let's do this, and that. Okay, white wins. There we go. So it looks like the checkmate detection works. I'm pretty satisfied, to be honest. The only thing missing, again, is castling. Would be lovely to castle. I don't think it's really possible to play a game of chess without, like, having the ability to castle, so that definitely needs to be in there. But other than that, you've done a pretty good job. I mean, one thing we actually didn't test out is en passant. But I'm sure that probably won't work if you can't even castle. But let's reboot this. Okay, so for this, we're just going to advance something, and then let's try this, and so you did en passant, but you did not do castling. Wow. Okay, anyway, let's just dive into the code. So the first thing I'm actually kind of, Quelldateien, source files. Ah, yes, you mentioned you're from Germany. Cool, Quell. For those of you who don't know, I went to school in Germany for a while, so I know German kind of decently, but I've never kind of interacted with computers, well, at least programming-wise in German. So this is kind of interesting to look at because Quell or Quelle means like a kind of a spring, like a spring of water. That's how I've kind of used that word before. So it's interesting seeing it as literally like source. Quelle, here we go. This is what I'm talking about. That is what I think of when I look at your source code. All right, anyway, so main loop.run. I love this. I love how clean this is. Let's get rid of that bright light. I love how clean this is. It's nice. You know, you have a static function here, which again, you know, like not too bad. You know, when you have something like this, class main loop static void run, from what you mentioned, how like everything, it looks like, you know, bishop, king, knight, all of these things are separate classes. You know, I can see that you're very object oriented. Like literally you're oriented around objects. You're used to using objects, but in C++ we don't have to do that. And for something like this, right, again, I would recommend that maybe it would be better to just have like a static void main loop. Doesn't have to be static at all. Maybe chuck that into like a namespace called chess or whatever the name of your program is. But otherwise, I would just have something like this and then implement it in the thing. Static is really only if we want to have it like within one translation unit, which we don't really. Or I mean, I guess if I'm explaining, I should explain it properly. Static in this context kind of means that it's going to be local to a particular translation unit, which is basically a CPP file. So if we include this header file in multiple files, they're basically going to have their own version of this main loop function. Or if you just include it in like a CPP file, then this will not be a global function. It will only be visible inside that one kind of CPP file. But anyway, obviously, since we are just doing the definition in the CPP file and the declaration here, we can just leave it at that. I would do something like that instead, right? And then obviously this would look something like chess main loop, right? Or you could even call it chess run or whatever. You're kind of just moving the main function over there. It's not a huge deal or anything, but I guess I would just encourage you to think about like the fact that you don't really need classes. Why is this a problem? Well, again, it's really not a problem, but you could do interesting things like this, right? Which doesn't really make sense. And I mean, you can technically write code like that as well, even though it's static. So I think in general, it could be a cool exercise for you to kind of try and sway a little bit from the path of the objects. Anyway, let's take a look at this kind of main run loop. First of all, I really am digging how clean the code is. Like, honestly, like there's no fluff anywhere. It's just like main run. Then we have a run function, and then here we have everything. You know, sometimes I really like code like this for simple applications like this chess game. Why? Because instead of having like an init function and then like init this other thing, I mean, we do have a handler init over here, but like my point is, instead of having a billion functions and then it being really hard to navigate, everything's really, really clear. And that's always something we like to aim for. Okay, SDL handler, we make a new instance of this and then initialize it. Again, I have a feeling straight away that this should not be a heap allocation. But let's take a look at this. I mean, there are quite a few things here. It doesn't really matter though. Okay, so public. So const int screen width and screen height, 640 by 640, fixed. Would be nice if it was resizable. And then we have a window we'll be rendering to while you're even using the m underscore. If you're using like m underscore and all of that stuff, I'd probably make sure these variables are private. I'm not sure if you use them outside of this. You might, I guess. Yeah, I mean, you use m event here. The whole kind of way that I like to use that m underscore convention is for basically private member variables. So if something's public, I'll usually just slap it in like that. Just so that it's kind of clear, but private members I like to prefix with this m underscore variable. Again, just a personal opinion of mine, nothing actually physically wrong with this, it's just more of a code style. Window we'll be rendering to, service contained by the window renderer, event, like mouse click, etc. This is kind of nicely annotated. Initialize the field, I'm not sure what that means. I guess you mean initialize these things, the fields. Returns true if everything worked, okay. Clean up. Destructor. So, you know, this is one of those things where I would probably do the init in the constructor and then the cleanup in the destructor, because you can kind of take advantage of objects, right? This is a good time to take advantage of objects. Speaking of taking advantage of objects, one thing you could also do, because I'm sure that you call handler cleanup at the end, is you could get rid of this, not call cleanup at the end, but instead just make this a stack variable like this, and you're going to be taking advantage of RAII, resource acquisition is initialization, which basically just means that your constructor is going to initialize stuff and your destructor is going to de-initialize stuff, and that process is going to be automatic because it's going to revolve around the whole way that stacks work inside C++. I think I have a video about like stack stuff, like using stack scopes, scope lifetime, something like that. I'll have that linked up there. Definitely check that out. You did mention that you've seen the C++ series, so maybe you've already seen that video. It goes into more depth about what I'm talking about. But anyway, the way that we would set that up here is by basically creating a constructor as well as that destructor that we've already got. What does the destructor even do? Nothing, right? So this is going to be perfect. And then we would just call cleanup from here and then call init from, well, I'm kind of did that the other way around, but we would call cleanup from the destructor, init from the constructor. That means that, again, we don't need this and we don't need the cleanup that I already removed, right? And then basically this handler arrow becomes handler dot. Then we'll just replace that everywhere in this file. And then we're basically good to go. This game seems to take in a pointer, so we can just give it the memory address of this. Let's double check to make sure that all of that worked, but it should. And it looks like we are good to go. So this is a great example of where it's important to not allocate memory on the heap all the time, not only because you then manually have to delete it, which, by the way, now that I think about it, you were never doing, right? So you didn't have like a delete handler. at the very end, right, which you need to do. I'm assuming you also haven't done that for game. So these are all kind of memory leaks. They're not really big deals in this case, just because this basically lasts for the lifetime of your whole application. So I don't know, maybe you're like super cool and you've deliberately not deleted that. I would delete it anyway, just in case the destructor is running certain code, but also just to be kind of clean, right? So in this case, you would come over here and then you would type in delete game, because if you've manually allocated something with new, then you have to destroy it with delete. But again, instead of doing that, you could use smart pointers by just writing something like std unique pointer, which kind of uses the same concept as this. It just wraps this kind of allocation in a class that will be automatically destroyed at the end of the scope, right? Because the unique pointer itself is allocated on the stack. And then you would just do std make unique and then pass along the arguments like so, right? So by doing that, what it means is everything else remains the same, but it just means that the destructor gets automatically called. You don't have to call delete. And by destructor, I mean like the unique pointer class itself will call delete on the object that is inside it, right? So game has a new kind of game object inside it. When this unique pointer is destroyed, when it goes out of scope, it has some code in its destructor that is basically this, right? So it will in fact call that for you. Okay, moving on, quit. So quit equals false, and that's basically while quit is false. I personally don't like to write code like this. Usually you'll see code written like this a lot more often, right? So instead of actually doing equals false or equals true, you just write quit. Again, no real difference. It's just more of a stylistic thing that most people like to do. So I would rewrite that to that. And then what do we do? SDL poll event. And, oh, okay, that's cool. This is nice. So this game is entirely event driven, meaning this isn't like your typical, like, let's render frames as quickly as we can, or at VSync, meaning like 60 times per second or whatever your monitor's refresh rate is. Instead of doing all of that, this is basically entirely event driven, meaning that the game does nothing until you like click on something and then it re-renders the screen. So this is really cool, actually. That should mean that it's extremely like efficient. However, I don't think it is. The reason being that you're using SDL poll event in a while loop, well, this is the big while loop, in a while loop constantly, right? Without sleeping or doing anything. So what this actually means, most likely, if I'm not misunderstanding this, is that you probably have like 100% CPU usage just in that loop. So let's go ahead and open up Task Manager and see what it says about our chess app. Okay, power usage, very high, right? So the power usage is very high. CPU usage is about 5%. Now I have a lot of CPUs, like as in I have a lot of cores. I've got 16 cores, 32 threads, but you can see, I mean, the CPU scheduler is moving this around. Actually, let's make it just stick to one core. So if we go to details and then just set the affinity, let's just clear this. Let's go CPU 7, okay? So now it's only allowed to run on that one core. So if we go to CPU 7, which is this one over here, you can see how that is just completely maxing out, right? So power usage is very high and we are maxing out our CPU core that is running this. We have a thread fully occupied doing nothing but checking for events. And then of course, if I was to close this, then suddenly this core is going to be able to relax. Okay, so how do we fix this? Well, might be more simple than you think. If we change poll event to wait event, which I happen to know is another SDL kind of function that will actually sleep and release the thread while it's waiting for events, and we run this again, that one little change, if we go back here, let's take a look at what this is saying now. And check this out, very low, because nothing's happening, right? And then if I should still be able to move and everything should still be fine. But again, very low, 0.1%. And then if we come over into our CPUs, let's just make sure that that affinity is still set. Okay, let's go ahead and set it again. I mean, it doesn't really matter. Core 7, you guys kind of get the point. Then you can see that this is our Core 7. It's now doing probably other stuff because we are in fact doing pretty much nothing and we're using like 0% CPU usage, right? So that is a much better way to go than using 100% usage doing absolutely nothing. But point being, my main takeaway from this is that it's cool that you've done it in a loop, because I know that a lot of people would just kind of implement this as a game. And again, I guess there's not too much wrong with that, because it probably wouldn't take more than like a millisecond per frame anyway, and then it would just VSync, it would just wait, it would just kind of sleep. But doing it kind of event driven like this is just cool, because we haven't looked at anything like this before. Okay, moving on. So if handler event type is quit, then we set quit to true. I mean, it's probably not worth doing anything else here. I mean, quit probably would be the last event to be set, so it's not a big deal, but I would just kind of break maybe, or like, I don't know, continue, just in case you have some other code or something, just because it doesn't make much sense to me to kind of say that quit is true. Oh, this is this while loop. Yeah, so in that case, I would definitely break, right? Because it doesn't make much sense to me to kind of say that, okay, quit is true, but then let's continue checking like all this other stuff, right? Speaking of which, this event type, as far as I'm aware, is only capable of being a single type at a time. I don't think this is like, well, you're comparing it with equals anyway. So I would probably make these else ifs, just so that you're not checking each and every single kind of case, even if it's this one. Or I would just use a switch statement over like handler.mEvent.type, right? And then you can kind of implement all of your case statements like this, with like a little break over here, and then it would look something like this instead. And you can add scopes around them if you have any problems with like variable names or anything like that. So I would probably do something like this. Again, not a huge deal, but if you do go with if statements because you prefer them or whatever, I would just definitely use else if for all of these, just to make sure that you're not rechecking event states when you don't need to. With the point being that it can only be one type at a time. Okay, let's add that back in. Moving on. So handle event type mouse button down, and in that case we okay, so divide by 80. I'm assuming 80, 640, 80. Yeah, so 640 divided by 8 is 80, and there are 8. Okay, so we have an 8 by 8 grid. I didn't actually notice that it had 0 padding. Yeah, it has 0 padding, right? So this entire game area, 640 by 640, each cell, because they go from they fill up the entire bounds here of the window, they're 80 pixels each. And so what we're doing here is we're just basically converting this mouse button kind of X position. So where we clicked, we're just dividing it by 80 to get the coordinate of where we are in the world, right? So in other words, if this is like 200 pixels across or whatever, if we divide that by 80, we're going to get like what, like 2, because it'll be like 2.5, and then we'll round down to 2. So 2 is 0, 1, 2. We know that we're in this cell. So this is simply working out the kind of X and Y coordinate in this kind of grid cell coordinate system, right? And then it's called start, probably because we're able to drag it. And then that way we know where we drag it by also doing end inside this if mouse button up. So when we release the mouse. So this will render the possible moves if clicked on is not null pointer. Where do we, oh right, clicked on, right. So then what this will do is then use these coordinates to retrieve the piece that is there. So clicked on is now a piece, right, which is like a pawn or whatever, that is what we're dragging. And then if it's not null, which again, you can check just by doing that, right? This is also very popular in C++. Other languages don't really support this, but because pointers are just numbers, you can check them as if they were like Boolean expressions. So if the pointer has a value, then it's going to be true. Otherwise, if a pointer is null pointer, it's 0, which means it's false, right? So this is just a trick that not really a trick, but it's something that we do pretty often instead of having to write null pointer. But I totally understand if you want to write null pointer, just because it does make a bit more sense to some people. Okay, so if clicked on get team equals game get turn, this prevents us, I assume, from moving the wrong team's pieces. So we can't have 2 like black moves in a row or 2 white moves in a row. And then if that's both true, then we render possible moves. And then this is going to calculate all of the possible moves and then re-render probably like the whole board. Oh, no, this will just, sorry, this is just showing the possible moves. So this will actually kind of fill in the squares that we're allowed to move into once it calculates all of these possible moves. Let's have a quick look at this code. So, okay, so we're using a tuple here. So vector of tuples in, okay. So immediately I'm going to say I don't like this. I don't like to use tuples. Why? Because they make no sense. So this is pretty obvious move type, but int and int, I mean, I can probably deduce this is like the coordinate of where you're moving. But the thing is, if you had used a struct instead, So for example, you might have had something like possible move as a struct, and then you can have like X coordinate, Y coordinate, and, you know, piece, move type, you know, move type or whatever, right? This obviously makes more sense because you just have one of these. It's clear what these actually are because they have names. Performance-wise, it does not matter at all. Same thing, right? It's just more kind of from the code side to be a little bit better. And then when you use them, see, the problem is you're using std_get. So instead of doing that, guess what we would be doing? We would be doing value dot and then what we want. So like X coord. Instead of std_get1, which who on earth knows what that means, it's value.y coord, right? So hopefully you can see how much better and more clear this code becomes now. Now it is also possible to use structured bindings with tuples. So if you do actually really want to use tuples and not make a struct out of it, which again, I would make a struct, but what you can do is actually use structured bindings, which basically just means that what we can do is stick in some names for this here. I don't know why I got rid of const, but you know, like X coord, Y coord, and move type, we can actually stick that in over here, right? Getting rid of this value, of course. And then we just basically are expanding these, but also giving them names. So this just becomes that, right? And then this becomes that. So at the very least, you can do something like this if you are using C++ 17 or newer, because that is a relatively new feature. But again, I would just use structs, in which case everything's fine, even if you're using C++, whatever, C++ 1900. Okay, anyway, I'm gonna undo all of this so that we can still compile the code without me changing everything. But other than that, I don't really have any problems with this. You know, you're being a little bit inconsistent with your curly brackets here. You know, if you're using if statements and functions as next line, you should do the same for for loops. Not a big deal, obviously, just something I noticed. Set renderer, draw color, and then doing all of this stuff. So handle screen width divided by 8, again, getting the coordinate. Or rather creating the rectangle from the coordinate. So we're taking the coordinate. Again, you see what I mean? Like, this is so hard to read. Like, this is the X coordinate. std_get 0 value. That is the X coordinate. This is just terrible. Like, it would make much more sense if you had X coord or something like that here, or at least XC, even though that's a bit cryptic, maybe X coordinate, you know, just X. That would make much more sense. So that's kind of what I'm trying to communicate here. Otherwise, the function doesn't really have a big issue. So you're getting the screen width, dividing it by 8, which gives us 80, and then we're multiplying the coordinate by it. So we're going back from the kind of coordinate space, which is what these two values are, into screen space or into like pixel space, so that we can actually figure out what the bounds of this physical rectangle that's made out of pixels should be. And then of course this is just going to be like a width and height of 80 by 80. So I'm interested in what, like, because remember the pieces were blurry, right? So let's see what size the pieces are. Let's see if I can find them here. So we've got an image here. Can't open a file. It's a PNG file, man. Okay, so I found the pieces and it looks like they are 60 by 60 and you're rendering them as 80 by 80. So what I would do is just find some high resolution art, right? Have some high resolution pieces, because otherwise it looks bad. Or you can like reduce the resolution of the game, which is probably not good as well. Oh, I'm like crying from these allergies. So let's try and find, where was this? SDL like handler, I think. Yeah, so if we make this like 480 by 480, is that right? 60 times 8, yep. So if we rerun that now, then yeah, so that looks really crisp. Okay, so get some high resolution images, high resolution textures. 60 by 60 pixels is tiny. Like, what are you doing? Get some high resolution pictures. Okay, so that's the render possible moves. I mean, we didn't really finish this function, but it's pretty simple. All we're really doing is rendering like filled rectangles here, and then we are rendering, what's this rendering? So this is going to, oh, so it is going through the entire board and rendering it again. Okay, sure. So we are in fact re-rendering, I guess, everything. We rendered this rectangle, which looks to be like the possible move, and then we go through all of these and we render mfilled, which is the piece. So we render the pieces on top, I guess. Sure, say my name. Say my name, no piece here, okay. If handler is null pointer, sure. Again, this is probably a good place to use asserts instead of just this, because that would help you through development instead of having to watch the console like a hawk to see if something's gone wrong. You would get a nice kind of like a breakpoint basically appear here that you could just use to debug the current state of the application. Otherwise, yeah. And this is another kind of, see, first, second, like you don't want to be doing that, like a pair position of the piece. Make a struct called like point or something that just has two integers in it, x and y, and use that. That way you can use x and y instead of having to be all weird and use, first and second. X and Y would make much more sense, right? So structs are your friend. Okay, so pulling back into the main kind of loop here. When we do mouse up, it's going to undo render possible moves. Okay, right. So that's going to, I guess, render the board, but without the possible moves. That's a bit weird. Wouldn't you just render the whole board normally? Because again, this looks like it's getting the possible moves. So what exactly happens when we do mouse up? Oh, this doesn't work because, yeah, that's another thing, right? So all of your logic, all of your the mouse dragging code, for example, all relies on the cell being 80 by 80, which, isn't a huge problem, but you should use a variable for this, right? Just like you used a variable for like the width and height of the screen, right? So you can see screen width and, 8 you can just keep using, I guess, because it's not like that's going to change probably, unless you have some weird variant of chess maybe with more kind of tiles or cells, right? But like, I don't like the divided by 80. So you should probably have something like cell width, which will be like, 80. And that way you can easily change that to 60, or even better, you can just do screen width divided by 8, right? Because that's going to be that size. So I would definitely make a constant out of that, because otherwise, if you do change the resolution like this, then it's going to be an issue. But furthermore, it's not going to work if you actually make the window resizable, like I think you should. Okay, so back to Blur Town. If I drag this here, then yeah, it moves this here. But again, I'm not sure why you don't, because you definitely, you obviously have something that renders the board. So why would you not just, why do you have to undo that kind of rendering? I don't really get it. Where even am I? So undo render possible moves. Because after this, if it's a valid move, oh, well, I guess maybe, let's just quickly see what happens here. Maybe this doesn't happen when I think it does. No, it does. So what happens if we comment it out? Okay, right. So the whole board doesn't get refreshed. We missed this. So it must not, in fact, be because it's the background. I see. So you render all the pieces on top, but the background you basically never render. Okay, that makes sense. I'm not sure if I'd probably just re-render the whole background, to be honest, and not have to worry about undoing this, but I can see what you're doing now. You're replacing that kind of like greenish turquoise color or whatever with like white or with the dark square, whatever it should be for the particular possible moves. And then you're rendering the pieces on top of them. So see, this is another thing I would do. I would bring this out into a function like render pieces or something, right? That will just go through and do that. That way you don't have to duplicate the code multiple times. Like you've got it here, and then you've got the exact same code here, and then I'm assuming maybe in some other places as well. In general, of course, we try to reduce code duplication as much as possible, so that it's easier to maintain and change code as time goes on, because you don't need to hunt it down everywhere and see what it is. Okay, so X end, we've gone through that, clicked on it. So if we've clicked on something, if it's not null pointer, then we figure that out. Again, these states, this can just be combined, right? So you can just move this down here. It's not like X end needs to be calculated before that or whatever. That would just kind of streamline this a little bit more. If clicked on get, so if it's the same team, you have a lot of if clicked on get team equals get turn. Like literally you have this everywhere. If you see yourself kind of using this multiple times, I would definitely like take it out, is valid move or whatever. I would definitely like take it out and actually kind of, into a variable so that you can use it multiple times easily without having to write that same code multiple times. But even better, since you use it in really a lot of places, I would probably bring it out into a function called like is valid move for team or I don't know, is valid move, and just kind of use that instead, because that would just kind of save you from, you know, checking to see if the current team, if it's the current team's go. Is team's go or something like that? I don't know. I mean, what are you checking? Game, get turn, and clicked on get team, right? So is team's turn, I guess, would be good. All right. Yeah, and then what do we do? So game is valid move. So how do we calculate these valid moves? So piece get possible moves. Okay, so this is where we actually are getting into the hierarchy of our pieces. So we have a base class called piece, and then that has like a particular team that it's on. It's got a piece type. So one thing I would do with these enums is it looks like you have a lot of these kind of like empty or none. You have these like 0 states, but they're at the end of the list. What I would do is actually make them first, because this gives them the value 2, which doesn't make sense to me. Like, I think that none should be 0, and then you should go up like that, right? And same with this, like you should have empty as like 0. A lot of times I actually explicitly write 0 just so that it's clear. You don't need to, it will be 0 anyway, unless you start it with some other value like -1 or something. It's just kind of like equating, I guess, empty or none with false, and because false is also 0. So that's why I like to do that. And then you've got, again, you know, these possible moves, which, as I mentioned, should be potentially a struct. You're returning this by value, which I wouldn't do either because it's a member variable here. I would mark this as const and then have this be a const reference. That way you are not copying a vector and dynamically allocating memory. You want to kind of avoid those memory allocations where possible. And again, you know, this is like an event-driven game, so realistically you'll probably never see any performance issues with stuff like this, but it's still good practice like for the future. Team, get team, sure, set new position. Okay, again, I wouldn't make that a paired, make it a struct. We have a constructor for all these pieces, right? So I'm assuming you're calling this like however many pieces there are. How many pieces are there? I think like 6 per team, right? Like 12 different pieces? I think so. Okay, copy constructor, sure. Copy constructor. Why do you have copy constructor? What are you copying pieces for? This should, I would probably just mark this as a default, unless you're doing, because it doesn't look like you're doing anything special, right? And then in that case, you can just get rid of this, because it looks like you're literally just assigning these. I mean, I guess you're not copying the texture though. You're just setting the texture to null. I'm not sure if that's an error, but for some reason you're not, and you're setting this to false. So usually, unless you have a good reason for this, usually obviously copy constructors would copy. So maybe that is special, I'm not sure. Destructor rendered this piece, prints name of piece, calculate possible move. So I'm interested in this. Okay, so let's go into something basic like a pawn. So what does that do? Okay, so in the pawns constructor, we load the file. So I'm hoping you don't call this 8 times, or rather 16 times, 8 for each side. But we basically load, okay, so PDT for black, so I guess dark, and then light theme for white. We take in this handler. So this kind of object-oriented design I'm not really a big fan of either, because you're taking this handler, which looks like you then don't use anywhere, so I'm not sure why you even need it in the first place. But it's kind of creating this like, you know, it's almost like a circular kind of dependency. I mean, it's not going to cause really any problems. It's more of a design issue, right? Because the handler should be kind of, well, then again, it's the SDL handler. It's not like you're taking in the game, right? I actually kind of thought it was like the game. So you wouldn't want to take that in because you don't necessarily want the pieces to be aware of like the game, like the meta game and everything. The meta game should contain the pieces and it should be the one giving them instructions. But this is an SDL handler, which is specifically, I guess, like the rendering stuff, right? Draw rectangle, undo piece, render load image. Oh, right, it needs it for loading image up here, which is, again, fine, but I wouldn't assign it to a member variable because I don't think you need it. I mean, other pieces, I guess, might use it, but pawn certainly doesn't seem to be. Okay, calculate possible moves. So I guess this will go through and actually figure out, like, which moves are valid. So let's see how we do this. So it's checking, like, the current position plus the delta, and the delta is probably... right, MDY, direction the pawn moves. Oh, okay. So this is not like... okay, I see. This is like a fixed kind of delta. So this is just immediately a quick check to see whether or not like we are actually within the bounds of the board, because 0 is like the first tile and 7 is the max tile. So this is actually an interesting check because this is the thing that will promote us. That's one thing we didn't check actually, right? Because I guess the idea is if that plus dy is in fact 0, then we've reached the end of the board and we should get a queen. That's one other thing I didn't check. Let me check that quickly. Okay, so let's try and get rid of this. We'll just step aside and let this, oh, it's check, and let this win. Oh, look at this. This is a pleasant surprise. Nice. Yeah, that's pretty cool. Okay, so that works as well, which is nice. So this is just, again, calculating the possible moves. But I guess the move type here obviously becomes a new piece move because that's a promotion for the pawn. So that's a quick little check. But again, like it's only possible to do if there's nothing in the way here, right? So this is us checking to see this next position that we've checked is in fact the promotion, kind of the base rank kind of position. So that's kind of an easy, I guess. Well, these are pawns in general, so they're kind of easy. This is just a normal move, I guess. If that's not the case, again, we're just checking to see if it's empty or not. But then I guess this is where it gets interesting. One thing I want to mention about this code so far is that it would have really benefited from some annotating, right? You used comments a lot before in places that maybe are like a little bit meaningless, but then over here, you know, where like check for promotion or whatever, you don't have anything like this. So you really should use comments more like this, right? Because this code is a little bit, it takes a second to understand. So this is like the whole has moved thing, which I'm assuming, well, actually, looks like, see, this is public, so it's hard to check, but I'm assuming the has moved thing is the thing that gives you the ability to move 2 squares forward if you want on your first move. Anyway, I'm not going to spend time doing all of this. Here's a little en passant kind of section here, which again is a little weird because like this has a bool and int, so if true en passant is possible in the int direction. So again, this is set by kind of external forces, which you know, makes it a little bit harder to kind of sort through, but I guess that's probably necessary because it's not really up to you whether or not you can do that. So you can see over here inside the game, if there's just, I guess, some kind of pawn move that's happened, then we can set that to true in negative one direction. Anyway, like a lot of chess is obviously just really specific rules, and I don't think that I need to kind of go through all of this and explain or try and explain to you how it's implemented. It's all pretty like standard. It's all pretty much done by hand, right? Just kind of filling in valid moves. Like if we look at the knight, for example, you can see that we basically check for a grid, like grid kind of adjacent squares in a grid around it, right? So that we can kind of just see if there are empty squares there, or I guess squares with the opponent's pieces that we can actually move into. There's kind of 2 rounds of this as well. One which focuses on like the X and the Y, because this only iterates through the for loop a total of like 4 times, I think. And this does another 4, but in the other directions. Then we get impossible moves here. So this doesn't actually return them, it just calculates them, and then we get the possible moves here, and then we can retrieve them by calling like get possible moves or something up here. This kind of code is always tedious to do. I can see that you've done it like using for loops, which is fine. I probably wouldn't have done it this way, just because if you take a look at these for loops, they're pretty useless in the sense that what they're doing is they're checking 2 states. You're basically checking dy is -2 and then dy is 2 because you're adding 4, right? So this is checking -2 and +2, and then this is checking -1 and +1. So what I would do instead is I would actually create some kind of like array of certain moves. Again, I would use like a XY point class. So let me just, you know, break this down here. So we have XY, we have an array of points, and these are the possible squares or whatever, right? And you would need to obviously check this with the bounds of the board as well. But you could do something like this, and then you can just define these things, right? So I'm not sure. So I guess in this case, we would have 4, but then this also has 4, right? So in total, the knight has 8 kind of squares that it can move to. So maybe I would do something like this. And then you can just list them here. -2, 2, 2, 2. I mean, this was for the y, but I think you kind of get the point. -2, 2, and then for the y, again, for the y, we're supposed to have -1 and 1. So we can do -1, 1, and then we duplicate this, and then this time we can have something like that, right? And that's 4 of the possible moves. And then all you have to do is kind of iterate through that. So possible squares, and then let's just pretend we did actually have 4. Let's just add that there. And then let's just go through all of these moves, possible squares, and then that's your for loop done, right? And then you can combine them and just do them all in one. Because it looks, I mean, looking at this code, the way that you're calculating this, like it's all identical, right? Lots of code duplication there as well. So listing something like this out would be helpful. And then if you were really cool with your comments, what you could also do is attempt to actually draw out a board that would explain like what these points are. So this is just me being extra cool here. But you could basically say that like the knight originates here, and then what we're doing, we're going -2 and then -1. So we can move here, and then same but like +1, right? And then same but +2, right? So this kind of fills in these moves that the knight can make, but then also you would have like the other 4 that I mentioned we would also need to implement, which are these 4, right? And then this kind of is a nice visualization of what in fact we're doing here. And if you were even cooler, you could actually label these so that you could easily kind of validate them and look at it. I mean, I don't know, like none of this is necessary, but it might be kind of cool to just look at, you know, kind of visualize what you're actually doing. I don't know, maybe I should make like a little chess game in Hazel or something. That'd actually be a cool project for the Game Engine series, kind of Hazel 2D. But anyway, that's pretty much all of the code. Again, all of these move things, you know, textures, rendering. This just draws a rectangle with that texture. Again, that's where that kind of distortion is happening because you have the 60 by 60 texture, then you're drawing it to a destination rectangle that is 640 divided by 8, which is 80, right? So you're just kind of stretching it out a little bit. You're getting all that blurriness. But other than that, I think you've done a pretty decent job at everything. The code is relatively clean. There's a lot of, again, use of like heap allocated objects where they just don't need to be, right? I would like to see a bit more, you know, stack allocated stuff. Again, you don't really need unique pointer here. That was just an example. I would make it like that probably. And then, wait, actually, where do you make all of the pieces? I haven't really seen that part yet, have I? While I'm looking for that, I also noticed this. So calculate possible moves, again, takes in piece pointers, and then an 8 by 8 two-dimensional array of them. So this is kind of confusing. I probably wouldn't do that. I'd have like probably like an SCD array of like 64 of these. I like one-dimensional arrays more just because they're less kind of indirect when you're dealing with them. But you know, this might be easier, I guess. But again, you know, if you're dealing with one-dimensional versus two-dimensional arrays, it's still, there's an easy kind of way to convert that, right? You just do like x plus y times width. So it's super simple. But anyway, let's try and find those pieces being created. So over here in init is where you create all the SDL stuff. Again, looks pretty simple. And here it is, the game class. Okay, so yeah, this is like a lot of stuff. I mean, you could have definitely used some for loops here. Because, you know, you're creating identical pawns, for example, here. I mean, obviously for some things you can't use for loops, but I would do that. This is also, once you've created the pieces, I'm glad that you kind of store the pieces somewhat permanently, so you're not like recreating them all the time. That's nice. Not that it's a bad thing to recreate them, but again, if they're heap allocated objects like that, as long as they're like fixed, I guess it's not too bad if you're doing that in initialization. But yeah, you know, going through all of these, then manually assigning them to like all the different cells, a little bit tedious, a little bit annoying, but more or less. Oh, actually, wait. Okay, so you're creating individual pawns. Yeah, so this is, again, like a situation where, you know, we don't need 8 pawns for each side, right? We really just need 1 pawn, and then we need to like render it many times and also keep track of 8 instances of it, but we don't actually need 8 pawns. So if I was to do this, I'd do it a bit differently, especially because every time you create a pawn, Every time you create 8 of these white pawns, you're loading the image repeatedly and you're storing like a reference of it here, right? That's completely unnecessary as well. They all look the same. You should kind of take 8 instances of them. When you're rendering, we'll actually have 1 instance of it and then just render it 8 times, for example. But then obviously you need to have some kind of lightweight kind of piece object or something that is just like, this is the piece, this is like what team it belongs to, this is its coordinate, and then, that's it, right? The type of the piece, and then that's it. That's all you need. So I definitely wouldn't set it up like this. And then you calculate all moves. So I guess these are like the starting moves or something. Wow. But then, yeah, you're going through, okay, so this is all of the moves possible for the current pieces on the board. Okay, so you kind of do that like up front, I guess. But yeah, that's pretty much it. Hope you guys enjoyed this code review. If you did, please don't forget to hit the like button below. Don't forget that you can send in your code to shonareview@gmail.com. There will be like some instructions in the description below, so definitely check that out. I never know what I'm gonna like review until I just open up that email address and I just get all of these messages there, and then I just pick. So it's always a blast, always a fun time, and never really know what's coming next. If you guys also have some like opinions about this code, definitely share them in the comments section below. But other than that, thank you guys for watching. Don't forget to check out Skillshare using the link in the description below, and I will see you next time. Goodbye.